What do you think that's going to be? Any guesses what that's going to be?
Would that be the driven or drive?
Actually, the other way, driver over driven. So whatever the rotational speed of the driver is compared to the rotational speed of the driven. So that's what that's going to be. It's going to be the driver speed
Driver over driven, is that what you said?
Yeah, driver.
Well, that's RPM, isn't it?
So you got to figure out what's my driver speed have to be and what's mine. So we want to know how fast is the driver shaft rotating, right? And then you're going to get you're going to figure out what you want, what's your goal. Okay, I want the fan to rotate this much, and that's going to give you a driver ratio, right? So then, after you know your driver ratio, then the next thing you're going to do is pick your sheave diameters. And this will be from a chart, no math here. And the chart's going to look like this chart right here. And I think there might be one of those in that book too. And when you first look at this chart, it's a little bit confusing, so you got to read your directions carefully, because it'll say, what you're going to do is first you determine the appropriate size of the smaller sheave, as shown in figure 33, and figure 33 is here, so you're going to choose that sheave diameter. And then the larger sheave is found by using the drive ratio. So from this table, you must find the sheave that meets all the following requirements. You need a sheave that is both strong enough and large enough to meet the horsepower requirements. Remember, here's our horsepower requirements up here, 6.5 horsepower requirements. You want to use the fewest number of grooves possible. If you can get away with one groove, that's what you want to use. Cheaper and less belts. Right? So you want to use the fewest number of grooves possible. You want to use the smallest diameter sheave that'll meet the requirements. Smallest one that'll meet the requirements. You don't want to put these big sheaves on if you don't need them. Why not? Who cares what size the sheaves are? Why not use a big one?
Because it would change the speed and torque.
Well, but as long as I got the speed right, who cares whether I use
Space.
Might be space, yes, possibility. What else?
Horsepower?
No, my horsepower is going to be good.
Start to stop applications have changed just how much attention they end up getting on the driven end of it.
Mm-hmm. But wouldn't that be a positive thing? If I had a bigger sheath, I'd have more contact.
Yeah, but you also got more centrifugal force.
Okay. One thing you're missing though.
Shaft.
Not so much a shaft.
A larger sheave will probably cost more money.
Might cost more money.
And if you have a larger object, the inertia from stopping it would have more backlash.
Maybe.
Would it
Yeah.
wear faster?
No, they don't wear any faster. But isn't it going to have to be longer?
Oh, yeah.
Right? If you got a larger sheath, you're going to have a longer belt. If you got a longer belt, it generally costs more money. So there's a couple of different reasons. So when you use that sheath diameter chart, part of the step it tells you is you got to calculate the size of the larger sheath, and you do that by multiplying the small sheath diameter times the drive ratio. So once you know the drive ratio and you've picked the smaller sheath, that's going to tell you what the larger sheath is. Right? The smaller sheath diameter times the large ratio. So what you're going to do is you're going to look at, in this chart, you have the RPM of the smaller sheath on the left. So let's say in this application my RPM was 2,000. So my smaller sheath is going to be rotating 2,000 RPM. So I'm going to go to that line and I'm going to go across until I hit the figure that's higher than 6.5. Right, so I go across and then over here, that happens to be up here, then that's a 5. So that's going to tell me what my big sheath is. Right? So I'm going to come down here with my speed, that's going to tell me what my small sheath diameter is. So my small sheath in this situation, 6.5 horsepower, 2,000 RPM, I need a 5-inch smaller sheath. Right? And then I'm going to take that and multiply it by my drive ratio because, right, you want those two things to be in ratio so you get that right speed. and that's going to give me the size of my larger speed. So if my drive ratio was 2 to 1, then I want my big one to be 10, right? So then the next is the number of grooves. So I figured that out, and so step number 5 is the number of grooves. It's really the number of sheaves. It's a little bit misleading to call it number of grooves, but it's really, how many sheaves do you need? Or how many grooves do you need in the sheave? How many slots do you need in the sheave? This is simply you take the design horsepower divided by the horsepower of the selected sheave. So the number of sheave grooves, it's a real simple formula. So you take the design horsepower, which is this right here. This is the design horsepower right here. So you take the design horsepower and you divide it by the horsepower of the selected sheave. So I guess each sheave has a horsepower rating. So remember up here, I figured out I needed a smaller sheave of 5 inches. And so I go to my bin and I go to my 5-inch sheaves and I pull one out and I notice it has a 3/4, or let's say it has a 3 horsepower rating. What's that tell me then?
Need 2 sheets.
I'm going to need 2. Actually, I'm going to need more than that. I'm going to get 6.5, so I'm probably going to need 3. Right? Now, if I have a 5-inch sheave that's rated at 10 horsepower, I'm good. Some of that's going to be the material it's made out of. I'm not sure exactly how the sheaves get rated in their horsepower. So that's going to be step number 5. And then finally, after all this stuff, and this is probably the trickiest one, I have to determine the length. And again, if you're out and you're working in a factory or a distribution facility, and you're mostly going to get into this when you're setting up something new. You got a new application, you got a new pump that's got to run faster, it's got to run slower, and so it might be up to you to figure out, okay, I got to set this system up, and I got to make sure I choose the right belt, and I got to choose the right size belt and all that stuff. So this is a little bit trickier. It's a pretty big formula. We don't expect you to memorize this. You can always look this stuff up. To me, don't memorize anything you can look up somewhere. But it's good to know. But anyway, the length is equal to, it's a really long formula. It's not a hard formula, but it's a long formula. 2C plus 1.57D plus D plus D minus D squared over 4C. Man, what a formula. Holy mackerel, I gotta do all that to figure out length.
What are all those E's?
Oh, we're gonna go over that. We're gonna get that. It's a good question, Steve. Good question. What are all those things? Well, what do you think L is?
Length?
That's the length. What do you think C is?
Center. Circumference?
No, that'd be a good guess, but the C is the distance between the centers. So I have a sheave here, and I have a sheave out here, and the belt's got to go between those. Makes much sense. Well, I better know how far those two are apart, right? I don't know how far those two are apart. I'm in big trouble. I got to know. So, what do you think the big D is, Dalton?
Diameter of the larger sheet.
Yep, it's the diameter of the larger sheave. That's why they made it. And it's the pitch diameter. So it's the pitch diameter of the larger sheave. And then obviously the small d is the PD of the small one. Where do they get 1.57? Why that number? Of all the numbers they could have used.
It's the one they pulled out of the hat?
No, it's a little more scientific than that. Chris, what do you think? Where did they get 1.57? I bet you can figure this out. Why 1.57? Why not 1.5? Why not 0.2? 2.0?
Half a pie.
Exactly, Ed! You get the prize. It's half a pie.
I'm hungry.
Hey, it's a half a pie. I like a whole pie myself, but that's exactly what it is. It's half a pie. I'm glad you figured that. Excellent, excellent. So you're gonna plug into this formula. You know, what's the distance between the centers? You know, take pi times the two pitch diameters added together plus the pitch diameters squared divided by 4 times the center. Now you think, okay, I'm done, right? I got that. Now you're not done. Next thing you got to determine is the corrected power per belt. So that's number 7. The corrected, and this is a step that I don't always see in all these things. So maybe this is very exacting. So in order to determine, it's the horsepower that a single belt can handle is called its horsepower rating. And that's determined by the strength of the belt. But there are other factors that have to be taken into account, such as the sheath ratio, the belt length, and something called the loss in arc contact. Remember, Ed was talking about how much contact is made with between the sheath and the belt. Now think about that. In this situation right here, depending on the size of these sheaths, I have contact between about here and here. I probably have contact for over 180 degrees on that smaller one, right? And then on this bigger one, I have contact between here and here. So I have this area of contact that I need to worry about. How much time is the belt going to be in contact with the wheels? Right? So I'm concerned about that.
You know, I think you're more likely to get the over 180 degrees on the larger one.
Right, yeah, you would. You're right. This would be the smaller than the 180, and this would be the larger than the 180. That's exactly right. So what you're going to do is, after you know that thing, a faster belt, the faster belt travels, the more horsepower it's capable of transmitting. For this reason, a correction factor must be added to the rated power of the V-belt. To add the sheave ratio correction to the basic horsepower rating, you must locate the correction factor in the chart. So again, you got another chart. So this is going to be from the chart. No formula. This is a chart thing. And when you get into this, you can see it's very similar to the other chart that we used. And you're going to figure out what's the RPM of the smaller sheath, and then you're going to look across, and you're going to find you know, your drive ratio, and then you're going to go down and it's going to tell you what the correction factor is. You're going to add that factor into this corrected power per belt. And then once you have the corrected power per belt, and still in step 7, then you got to do the loss in arc contact. So again, that's going to be another, this one is a formula. And the loss of arc contact is, so this is from the chart, but in this same step, loss of arc is going to be big D minus little d times 57 divided by C. Now, if you had 2 pulleys that were exactly the same size, of course, you would have 180 degrees of contact here and 180 degrees of contact over here. But when you don't have that, on the smaller pulley, you're going to have a little less contact. On this one, in this case, you might only have 150 over here. And on the bigger one, you're going to have a little more than that. So this formula is going to help determine that. And now, on this question, why 57? I don't know. It's because that's how many varieties of Heinz ketchup there are. I don't know. Who knows? Somebody knows, but they're not telling me why. And then you're going to get a loss of contact correction factor depending on the loss of arc in contact. So when you come out with this factor here, if your loss of arc in contact is, for example, 25 degrees, then your correction factor is going to be 0.93. So you're going to take your horsepower and multiply by 0.93. And then you're also going to figure out the belt velocity. How fast is the belt turning? And all that's going to help you figure out this corrected factor. And then to figure out the total corrected factor. And that's the thing. And maybe this is where they're combining two together. I guess I need more board here. This would be 8 is the total corrected factor. And in the lap, it's going to run you right through all this, every step. And it'll tell you, look at the chart on this page, and do this and do that. It won't be very confusing at all. So that's going to be the corrected horsepower of each belt times the total number of belts used in the system. So you get this corrected, and if it comes out to 0.93, you got to take 0.93 times 3 if it's a 3-belt system, 0.93 times 2 if it's a 2-belt system. So 1-belt system, it's just a single number. And then, after all that, you compare the corrected total horsepower to the design horsepower. So you compare number 8 So you compare those two numbers. So remember we had that 6.5 before. And in this step you verify that the corrected total horsepower is greater than the design horsepower. If it's not, you got to redesign the drive using larger sheets. So when you get to this point, this number is not bigger than the other number, it means that you haven't used big enough sheets.
6.5?
Well, no, it's not always going to be 6.5. Remember when we did this step up here when I did that was 6. So no, it's not always going to be 6. Whatever it is, though.
All right.
You know, so if your design horsepower is 3, your corrected horsepower should be 3.1 or 3.5 or 3.6. And if it's not, it means you probably chose the wrong small sheet, and you got to go back and make that sheet a little bigger, and then it should work out. I don't think any of the problems do that. If I remember right, I don't think they do. And then the last step is then you're gonna select your bushing. Right, so that's the very last step is then you're gonna select your bushing, and that comes from the chart. And so compare the corrected to the design horsepower, and if the corrected, I'll put this up here, is less than design, you need to pick a bigger sheet. And that would be back here in this step right here. Again, I don't think any of the ones do that, if I remember right. And then so step 10 is to select your sheet. And so again, you're going to have a chart for this. And on the left side, there's going to be your different sheath diameters. So if you're using, for example, if you're using for an A belt, if you're using a 7-inch sheath diameter, and you look across, it's going to tell you you need an AS74, or you need an AK74, or you need an AK74H, or you need a BS80, or you need a BK80. It's going to give you a list of the sheets that will work under that application. So that's the 10 steps of designing the entire system. Now, you know, again, you may have to do this, David can tell you better than I can, once a year, once every 2 years. Just the fact that you know how to do it might be a big plus for you, you know, because if you got an engineer that comes down and you know what, they probably cover this in mechanical engineering school for about a half an hour, you know, and so in 4 years you got a half an hour, and then all of a sudden you're pushed out into some factory somewhere, and you're supposed to be designing a belt drive system, and you have the foggiest idea what to do. As a technician, if you can walk up to that engineer and say, hey, you know, there's this 10-step process that we learned you know, can I help you with that? That'd be a big plus. You know, and that, again, that's what we're all about, is making you guys so that you're value added to the company. So that you maybe, I would venture to say, if you went out and asked 10 technicians at any company in this area, there's probably less than 20% that know this process. Now, some of them might say, oh yeah, I remember I learned that sometime, but you know, I don't know how to do it. So, you know, all these little things like this, and again, we don't expect you to memorize them, but the fact that you learned them and you say, oh yeah, I can go back to that, you know, 10-step process. And again, you don't have to memorize it. If you look, it's on the web. I don't know if it's in that book or not, but there's plenty of places that you can find this out. So that's it for tonight. So that's your next. That's lap. Drive 2's lap 2.
Yes, back there.
Yep, it's back there on the thing. It's really one that you can almost do. You don't necessarily need to be here to do it. I mean, there's a couple where they tell you to grab the belt and measure the belt.
Yeah, this last one down here, we got to measure the certain belt.
Yeah, a lot. If you want to take it with you and you know, knock out what you can do at home, and then just figure out what you need to do here, and it's just again using the things in the VBelt. If you haven't signed up for advisement, do that.
11:30.
You didn't get this part.
Yeah, no, we said. Everybody else get in here.
Basically,
I might not be here.
we have an agreement that you're.
I'll be here at 12.
You sign, your whole signed up, the whole thing.
Okay. I'll get out
Keep it your.
9:10.
You said, okay, today.
I'll be-
I didn't know. You guys use the old.
I know.
But you have to be real detailed.
One job I should.
Yeah, that's just the last one.
Yeah.
Yeah, or whatever you do. And then, you know, of course, we look for something that's
necessary. I don't think he, you know, really wants us to
and
do it
then
because
you
all
have
it
to
does
write
is prevent
a
belt slack.
small report for the company.
So, you know.
Almost like
it's
we
not-
did in mechatronics.
You know, it's gonna change anything.
For the company now that you're actually working on it.
Right.
So that's a, you know, a couple of page report. And then, there's an evaluation that
I don't know.
your supervisor will do of you, and that has to be in there. Your resume has to be in there, and, Sissy, and your,
I guess I'll see you fellas Thursday.
yeah, about 4 or 5 things happen. It's just a little report that you can.
How early can you make it?
And that's I forget what percentage, that's like 40% a year, or maybe more than that. And then your supervisor's evaluation is a certain percentage of your age.
You can get in there, too.
Yeah, me too.
Yeah.
Where do you go?
All right. We can probably do that now.
You want these back?
Yeah.
Yeah.
I'll be
Where
here.
do we get these?
You want one?
If you're not here, I'll be working.
All right, yeah.
All right, I'll see you Thursday.
Okay, I signed up,
This is it, in a
the paper
nutshell.
on your door, and so I'm supposed to be here, I signed in for 9:20.
Yep,
So I'll be here.
Yep.
9, in that office.
yep, that's where we'll be, either me or Dave, or one of the two, and we'll get you all straightened out, and get you all scheduled for next semester.
How is it?
See, this is good for the team. You know, it's everything that we've been going over for the first couple of weeks.
Yeah, it is a nice document.
Mm.
And it's got, you know, one of the things I really liked about this thing, it shows you that how the different, using the different devices. So if you use the thumb test that, you know, 90% of the technicians use, you're going to have about 65% accuracy in determining the tension of your belt is correct. If you use the plunger like that we have, you're going to have a 90% accuracy. If you use the frequency tester, which is this thing, you're going to have a 99% accuracy. And if you use this tension right, which is, I tried to get one of those from Goodyear, and they wouldn't give me one. They're supposed to be about 93% accurate, so they're actually supposed to be, it's a non-mechanical thing, it's supposed to be as accurate as the plunger. But these things are about, I think they're about $500. They're frequency meters.
And how much use do you get
I
out of
don't-
it to justify the cost?
Well, yeah, right, I mean, okay, let's see, I'm gonna get 90% and compared to 99%, it's pretty,
Yeah.
I guess if you got a ton of belts in your facility, and if they're expensive belts, if you've got a lot of the positive drive belts that are expensive.
Yeah. But, you know, That's where.
I already did,
You already did.
I've already took care of that.
Okay.
All
All
right.
right. Okay, yeah, I'll be here about 1, I'd say.
Okay.
Yeah, we'll go ahead and get that taken care of and.
Yeah.
Not for nothing, but it seems that if you're using a frequency reader, you know, then you have, like you said, you know, so many belts, and you're also apparently concerned about the consistency of the torque, you know, right?
Yeah,
So then,
I'm with you.
yeah, so wouldn't that mean that basically you just need to run around and check it every day?
Yeah, if you check it more frequently, that's exactly right. Yeah.
Uh,
But they tell you in here too, that's another thing in that book, it tells you, you should check it after it's run for 24 hours.
Mhm.
And then you should check it again after it's run for like,
6 weeks.
yeah, and then, and, you know, and so that way you're pretty much, this is a special one. This goes over here. And let's see, one of these
So fast.
goes on here, and it's my error down. Yeah, the A34, A58, and then it goes on here too. Hold on.
Well, see you tomorrow, Alan.
Yep, I will see you guys.
Do we
Okay.
know, any more about the internship? Like, will it be morning, or is that all gonna be left up to the company?
That'll be up.
Is that-
That, I won't say be totally left up to the company, but it'll be up to the company. And if they choose you, as they say, okay, I want to interview Jason. So you go in and you interview and you say, okay, here's my situation. And you'll try to negotiate, work out that with them. And I think most of them will be flexible enough that they can say, okay, you want to do mornings, let's do mornings.
Oh, so there's a chance that it may not do the internship. Well, let me ask you this.
You're
Will I-
going to get an internship. I mean, I can't guarantee it's going to be at S-Rock, but
Right.
I'm, you know, just looking at the candidates we have for internship and the number of internships we're probably going to have, I don't think you have to worry about whether you're going to get an internship.
Yeah, because like I said, I need to give my employer
Some
some
notice.
notice.
Yeah.
And now it's about that time.
Okay, I'm gonna try to get, I mean, I've got it out to the companies, and what I'm probably gonna have to do next week is actually start making some phone calls and say, remember that paper I sent you? We didn't have it back yet. Because what I wanna get from them is what they expect, like how, you know, are they gonna expect somebody to work so many weeks, so many hours, so many days? How do they want to handle the interview process? Do they want to come here, interview all the candidates? Do they want to post an internship posting and have the candidates go there and say, yeah, I'm interested in posting? You know, I want to give them some flexibility as far as how their HR works and stuff like that. But I think all these companies are going to be flexible enough that if you go in and you say, well, this is the schedule that works for me, they're going to say, okay, that's good.
Oh, okay, all right.
I don't think they're going to come in and say, oh yeah, we expect you to be here from 8 to 5. Monday through Friday for the next 8 weeks. I don't think they're going to do that. You know, I kind of laid the groundwork for that. You know, a lot of our guys already have jobs. You know, and they're going to try to work this in with what they already have. You know, some of them might take 2 weeks of vacation to do it. Whatever, you know, however it works out.
Oh, so it's only be 2 weeks?
It could be as little as 2 weeks if you
Oh,
wanted
really?
to be. Yeah. Yeah, because you only need 45 total hours to get the 3
So
credits.
it's 45 hours, okay.
So if you did, I mean, we would like it to be as long as you guys can negotiate, and you can work out your schedule, because the more time you get in there, the better it's gonna be for you, you know, and then they're gonna get to know you better. But if in your particular situation, if that would work, man, I could give them 40 hours, I could give them 80 hours in 2 weeks and knock it out and get it done with, that's the way I prefer to do it. Well, let's talk to them. You know, and then that might also affect, you look at the internship posting and they say, no, we want somebody for 8 weeks, 40 hours a week for 8 weeks. You know, that's what we want. And then you're gonna say, well, I can't do that. I can't do that. And another company says, hey, well, you know, we're more flexible, we'll work with you, then that might be the one you wanna look at. So that's what I gotta try to get back from them as soon as possible. And we'll post them out on the bulletin board, we'll put internship, you know, whether it's an interview time, okay, you know, S-Rock is gonna be here to interview interns Friday between 1 and 3. If you're interested, be here, you know, with your resume. Or they're going to interview at their office on Monday at these hours. If you're interested, go interview, you know, get it done. That's how we're hoping to do it, because that's more realistic, you know.
Yeah.
Rather than us, you know, and there's definitely, there's definitely a couple of situations, and really I can only